So what I mean by talking about percents and fractions, all right? So we're going to make a percent into a fraction. So the good thing is the golden rule of a percent is that they are always out of 100. So like when you take a test, every test is out of 100%, unless you get like extra credit and all that. That's different, okay? But every test or anything is always out of 100%. So when you go to make a a percent into a fraction, your denominator is always going to be 100. Always. That's where you always start because it's always out of 100. So whatever percentage they give you, so like that first example, they gave us 15%. So 15 goes in your numerator. All right. Now we have to simplify it. So, because they want you to put this in simplest form. So that's the first initial fraction. That's how it always begins. Always goes over 100. You just put your percentage in the numerator. Now we have to simplify. So is there anything we can simplify out of this? Hunter? 5. So you get 3 over 20. And of course my marker's crapping out on me. So if you get something like this, let's say 7%. Okay, so 7%. So once again, it always goes over 100. So it's 7 over 100. Now, can we simplify that one? No. Nope, that one's done. Okay, so that's how you do this. That's literally how you change a percent into a fraction. Put it over 100 and then simplify. It's as easy as that. So I want you guys to try to do 1 through 6 down at the bottom. So you're changing each of those percents into a fraction in simplest form. So just start off by putting the percent over 100 and then simplify it if you can. You won't always be able to. All right, so go ahead and get started. I'll give you a few minutes. So number one, we have 20%. So what's our first fraction going to look like, Hunter?
20 over 100.
20 over 100. Okay, so that's how it's first originally set up. Now we have to simplify this. So what are we going to divide out of both of these? Katie? 5. Okay, so you get 4 over 20. Are we done? No. Okay, we can still go further than this. We can take a 4 out now. So we get 1/5. So remember, you got to put it in simplest form all the way down. So you got to make sure you can continue to divide. All right, so number 2 was 35%. Well, 35% would be 35 over 100. Now, what are we going to divide out of these two? What can we divide out of both 35 and 100, Hunter?
5.
5. So you get 7 over 20. All right. Okay, number 3, same thing, 70 over 100. So what are we going to divide out here, Hunter?
5.
Okay, so you get, what would it be? 14 over 20. Are we done? No, we can keep going. So I'm going to take a 2 out. So I get 7 over 10. Okay, you could have done it this way on this one where you could have divided by 10 from the get-go. Like I said, it does not matter what you divide by as long as you divide all the way down to this one right here, that one right there, that one right there. Because there's all kinds of different numbers you can divide by. It just depends on how far you got to go. You got to keep simplifying until it's all the way done. That's a little bit better. Okay, so number 4, we have 60%, so it'd be 60 over 100. Now what do we divide by? What can I take out of both of those? Well, if they both have zeros, what can you divide by if they both have zeros? 10. So if I do that, I get 6 over 10. Are we done? No, they're both even, so I can take a 2 out. So I get 3/5. Okay, number 5, 30% would be 30 over 100. And once again, they both have zeros at the end, so we can divide a 10 out. So we get 3/10. And number 6, 25 over 100. So what do we have to do here? Divide by 5. So you get 5 over 20. Are we done though?
Yeah. No.
Nope. Nope, because we have 5 and 20. Both of those are divisible by 5, so I'm going to divide a 5 out. Well, that'd be 1/4. Okay. All right, so that is how you change a percent into a fraction. Now we're going the opposite way. We're going to take the fraction and change it into a percent. Okay, so like I was saying before, the goal was to get 100 on the bottom. So, because all percents are out of 100. So when they give you a fraction like this, so like 1/4, your goal is to try to get to be 100 on the bottom. So we got to go from 4 to 100. What do we have to do to that 4? What do we have to do to that 4 to get to 100? By what? Yep, multiply it by what? Does anybody have an idea? So you're going to multiply it. What are we multiplying by? Well, let's divide it out. So 100 divided by 4. Well, how many times is 4 going to 10? As close as we can get. 2. So 2 times 4 would be 8. We subtract, we get 2. Bring down 0. How many times is 4 going to 20? 5 times. 5 times 4 is 20. We're left with nothing left over. So 25 is what we're going to have to multiply by. Well, whatever you do to the bottom, you got to do the top. Well, what's 1 times 25? 25. Now, since we have 100 on the bottom, we know this is our percent. So whatever number that is right there in your numerator, that's your percentage. So it's 25%. That's it. So your goal is just try to get 100 on the bottom. If it already has 100, your answer is your numerator. It's done. It's given to you. So if you had, I don't know, 3/5, something like that. Okay? Once again, the goal is to get 100 on the bottom. So we got to go from 5 to 100. So we're still multiplying. So what do we got to multiply by? Anybody have a guess? How do we go from 5 to 100? What do we got to multiply by? 20. Okay, whatever you do the bottom, you got to do the top. So 3 times 20, 60. So that number right there is your percentage. So it's 60%. That's it. Don't forget the symbol though, because that will cause it to be half wrong. All right, so I want you guys to try to do the bottom ones. So 7 through 12. All right, so you're changing those into percents. Like I said, if it's already 100 on the bottom, that's your answer. Okay, so go ahead and get started. All right, so number 7, we have 3/10. Okay, so we're trying to get 100 on the bottom. So what do we have to multiply by here to get 100 on the bottom? Hunter? 10. So that would be 30 over 100. So what's our percentage? 30. 30%. Okay, number 8, 2 over 100. What's that percentage going to look like? Katie?
2 over 100, and then the next one will be 100 on the bottom.
Well, it's already got 100 on the bottom, so what's our percentage?
2.
2. So that one you don't even have to change. It's already got 100 on the bottom, so it automatically knows your answer. Okay? So number 9, 8 over 25. What do we have to do here to get to 100 on the bottom? Hunter?
Times it by 4.
Yep, so then 8 times 4 would be 32, so our percentage is 32%. Okay, number 10, 1/5. Okay, so 1/5, we're going to have to multiply it by 20, so we get 20 over 100, so it's 20%. Number 11, 7 over 20. Well, we got to multiply that by 5, so we get 35 over 100, which is 35%. And number 12, that one's already got 100 on the bottom, so our percentage is 13. And that's it. Okay, are there any questions on percents and fractions? All right, now we're going to move into the next one, which is all about percents and decimals. Okay, so we're kind of doing the same thing, just a little bit different. And there's a couple of shortcuts I'm going to show you how to use. So, when we are working with percents and decimals, you're kind of doing the same thing as fractions, because we're working with the percents still, so we know that percents are always still out of 100. So if they give you a percent and they want you to make it a decimal, so they give you 23%, all right, and they want to make this a decimal. All right, we know how to change this into a fraction, because we know that they're always out of 100, so 23 hundredths. Well, since we talked about place value with decimals and fractions in chapter 1, I know this is read as 23 hundredths, or as a decimal, 0.23, 23 hundredths. So literally, if you want to take it to the fraction, that is fine because it's literally just going to be out of 100. So it's always going to be hundredths position. So it's always going to be point something and then another number in the hundredths position. Okay, so that is the all the steps way. Okay, this is why this works, because this right here is a fraction. All fractions are division. Okay, this bar right here is talking about division. All right, no matter what, every time you see a fraction, that's actually division. So since we're dividing, we can actually take a shortcut, because if we're dividing by 100, I know that there's a decimal after this number. Every whole number has a decimal after it. Okay, it's just not written because it's given. It's like the wind. You don't know, you can't see it, but you know it's there. It's just like this. Okay, I know there's a decimal there, but I don't have to write it because it's not necessary, because it's still a whole number. Now, since I'm dividing by 100, I can take this decimal just from the get-go and take it to the left 2 times. 1, 2. So it's 0.23, 23 hundredths. Same thing, but you don't have to go all those extra steps. The reason that works is because you're dividing by 100. Why did I move the decimal twice? Why did I move it 2 times?
Because there's 2 digits.
Nope. Why did I move the decimal twice on that? If I'm dividing by 100, why did I have to move it just twice? Why did I only move it 2 times? I could have done 5 times if I wanted to. Why did I only do it 2 times? Look at this number. What do you notice about 100?
If you didn't move it 2 times, it would be more than 100.
Oh. Why would we only move 2 times due to that 100?
Because 100 has 2 zeros.
Exactly, because it has 2 zeros. All right. So if it was 1,000, I would have done it 3 times, and so on and so on. Well, since it's 100, there's 2 zeros, so I have to do it 2 times to the left because we're dividing. Every time you divide, you always go to the left. Now, if this is if basically you're given a percentage, you always divide first. So it's like turning it into a fraction. All right. So we'll talk about the other way. Now, like I said, you do not have to use this method where you move the decimal 2 times. All right. That's just a shortcut. You can write it out as a fraction because it's always over 100. No matter what, we know that percents are always over 100. So all you're doing is taking that percent and changing it into a decimal. So on the front, I want you to try to do 1 through 6. Actually, real quick, I want to do this one real quick. 7%. Okay, we didn't talk about that. All right, so 7%. So like I was saying, it's still out of 100. So it's 7 hundredths. Okay, that written as a decimal, though, is 700. So it's got to be your decimal point, a 0, then the 7. It's not just decimal and then 7. That's 7 tenths. This is 7 hundredths. It's got to be that. Now, if you do it the shortcut way, that actually is given to you because 1, 2. What does this empty space mean? What do we have to put there?
A 0.
A 0. That's why I like the shortcut, because it stops you from doing this. I don't want you to do that. Okay, because it's 7 hundredths. It's 7 out of 100. All right? So go ahead and try to do 1 through 6 now. So all you're doing is changing those percents into a decimal. So 39%. So if I did it the fraction way, it would be 39 over 100, which I know is 39 hundredths, or that your decimal and then 39. And you guys can put the 0 in front of the decimal. You do not have to. I will never mark that wrong. Yes, that is the proper way of doing it, but you don't have to. Okay? So if you don't put the 0 in front of the decimal, I'm not going to mark it wrong because that does not make it incorrect. So number 2, 57%. So what would that be as a decimal, Katie? 57 hundredths. Okay, number 3, 82%. What would that look like, Matiana? 82 hundredths. Number 4, 13%. Hunter?
0.13.
13 hundredths. Okay, 8%. Number 5, Natiana?
0.08.
Good. And number 6, 4%, Katie. Nice. Okay, pretty easy stuff. All right, don't freak out when you guys see percents or fractions or decimals. They're actually really easy to work with. A lot of people look at them and they like freak out, but there's a lot of tricks to them. Okay, they've actually came out with a lot of shortcuts to make things easy for you. So the next part of this, now we're going to go the opposite way. We are going to change a decimal into a percent. So if they give you like this, 44 hundredths, 0.44, 44 hundredths. All right, they want you to change this into a percent. So once again, you can change it into a fraction just like before, but your goal is to get 100 on the bottom. Well, if we read this as 44 hundredths, this is already 44 over 100. So what's our percentage? Hunter?
44.
44. Okay, so that's changing it into a decimal or a fraction and then getting the percentage. Now, if you have like this, 7/10, 0.7, okay, that would be 7 over 10. Well, that's not 100. Okay, remember the goal has to be 100 on the bottom. So we're going to have to multiply that. It would be 70 over 100, which our percentage would be 70%, not 7. Okay, so the other way, that shortcut, so before when they gave you a percent, we moved it to the left because we were dividing. Now you're technically multiplying, so you take it to the right. So you take the decimal, 1, 2 times. So then you have your percentage, 44%. Okay, so like this one, 1, 2. And we have an empty space, so once again, we add a what? A 0. So we have 70%. Okay, so you can do it either way. I don't care. Both of them work. You're still going to get the same answer. So go ahead and try to do 7 through 12 at the bottom. So you're taking those decimals and making them a percent. So don't forget your percent sign. Okay, take your time. So number 7, we have 86 hundredths. So what's that going to be as a percent? Natiana? 86%. Okay, number 8, 36 hundredths. 36%. 9, 65 hundredths, Hunter. 65%. Number 10, Natiana. 20%, good. Okay, that would be 2/10, so you gotta move it twice, so it would be 20%. 11, 48 hundredths, Hunter. 48%. And number 12, 17 hundredths, Katie. 17%. Any questions on those? Okay, those are pretty simple. Working with percents and decimals are even easier than the fractions. So now we need to talk about how to compare in order fractions, decimals, and percents. So we've skipped lesson 4, and we're moving right into lesson 5. So lesson 5, like I was saying, is comparing and ordering fractions, decimals, and percents all together. Now, what they're going to have you do first is compare a couple of fractions. So when I mean compare, I'm talking about these symbols right here. Less than, greater than, equal to. Okay, so whenever you read these in a mathematical sentence, right, you always read them left to right. Okay, it's like reading a book. So this would be read as blank is less than whatever. Blank is greater than whatever. And blank is equal to whatever. All right? So that's how those work. Now, what they're going to do is give you two fractions just like they did on the front. So we have 1/3 and 5/12. And they want you to compare these. Okay, the problem is you can't just look at this and say, I know that 1 is less than 5 and 3 is less than 12. It doesn't work like that. In this case, it actually would in the long run, but there are going to be fractions where that does not work. So you have to follow the rules. Okay, so when you want to compare two fractions like this, you have to have common denominators. So basically, all you're looking for is that least common multiple we talked about in chapter 1. So you're trying to find a number that these two both multiply to, and they share it. Okay, that least common multiple. So what would be a common denominator for 3 and 12? Oh, because we can't divide. We have to multiply. 12. So, I mean, you're right. That's a factor. But we have to have a number that's bigger, 12 or bigger, basically. It's got to be the same or bigger than the largest number there. Yes.
So it'd be 12.
Yeah, you're 12. So the good thing is, this one we don't have to change. So I just leave it alone. And I always like to rewrite them because when you go to compare them, you have to use the original numbers. When you go to order them from least to greatest, you have to use the original numbers. So this is the only one we have to change. what do I have to do to 3 to get to 12 on the bottom?
Multiply by 4.
Multiply by 4. Well, whatever you do at the bottom, you got to do the top. So 1 times 4 will be 4. Now we can compare these. So all you're comparing now is just the numerators. So which one's bigger, 4 or 5? Just say it, 5. So we go back up to the original. We put 1/3 is less than 5/12. That's all you got to do, especially when it's just two fractions. Okay? So you just got to make sure you have two common denominators there. Now, what you're also going to see is something like this. 3 1/4, and we want to compare it to 2 3/8. So what do you think our first step is here? If we're trying to figure out which one's less than, greater than, or equal to.
You have to find the least common multiple.
Nope. Now with a mixed number, what do you got to do first?
Look at the big number.
Thank you. Look at the whole numbers. Isn't 3 bigger than 2? So automatically, before you even do any work, we know that 3 1/4 is greater than 2 3/8. I got everybody yesterday, so don't worry. Okay, so first thing you always should do when you get a mixed number, look at the whole numbers. Okay, compare them. So it won't always be like that, but they will throw some of these at you to throw you off. That way, I'm just trying to save you guys a bunch of work. You don't have to do it because automatically you can put your answer. Now, if they do this though, now the whole numbers are the same. Okay, now we're not worried about the whole numbers. Those are gone because we're not worried about them because they're the same. Now we're worried about, so I'm just going to bring these two down here because it has nothing to do with our fractions. Now we have to look for a common denominator. So what would be a common denominator between 4 and 8? Katie? 8. So the good thing is I don't have to mess with that one at all. So 3/8 down there. Now this 4, what do I got to do? Multiply. What do I multiply it by to get to 8? 2. So 8, and then 1 times 2 is 2. Now we can compare these. So the whole numbers are the same. Now we look at the numerator. So which one's bigger, 2 or 3? 3. So we go back up here, and 2 1/4 is less than 2 3/8. Okay? So whenever you have a mixed number, always check the whole numbers first, then go to the fractions. That way it just saves you a ton of work. Okay? So go ahead and try to do 1 through 3 down at the bottom. 1 through 3. All right, so number 1, we have 5/12 and 3/8. So 5/12, 3/8. Okay, so what is going to be our common denominator here? What would be our common denominator, Hunter?
24.
24. So we're going to have to change both of them. So sometimes you don't have to change one. Sometimes you got to change both. Sometimes you don't have to change any at all. It just depends. So what do we have to do to 12 to get to 24? Hunter?
Times it by 2.
Yeah. So you get 10 on top. And then 8, what do we have to do? How do we get from 8 to 24?
Times it by 3.
Yep. So then 3 times 3 would be 9. So now we have 10 and 9. So which one's bigger?
10, 24.
Yep, 10 over 24, so that would be the 5/12. So 5/12 is greater than 3/8, just like that. Okay? Number 2, we have 6/8 and 3/4. So what is going to be our common denominator here? Hunter?
8.
8. So this one we don't have to change. This one we got to multiply by 2, so we get 6 over 8. So what is this one?
Equal to.
Equal to. And the last one was 3 2/7 and 3 1/6. So first off, let's see. Well, both whole numbers are 3, so we're going to have to move to the fractions now. So what is our common denominator here? Anybody find that one? What is the common denominator between 7 and 6? Sometimes you literally just have to multiply the 2, so it's going to be 42. So we're going to have to change both of them. All right, so we had to multiply 7 by 6 to get to 42, so 2 times 6 would be 12. Well, 6 goes into 42 times 7, so we got to do 1 times 7. So we have 12 and 7. Well, 12 is clearly bigger, so 3 2/7 is greater than 3 1/6. Okay, any questions on that?